All right. So, lessons in professionalism, cholera, and the Challenger. It took hundreds of deaths, a priest and a doctor, in order to figure out the science of epidemiology. And that started in 1854 in London with what was the London cholera outbreak, or at least the 1854 outbreak. There were numerous ones before. There were not really any afterwards, and that's what we're actually going to look at to start tonight. In the first 3 days, 127 people died, which equates to one person every 34 minutes died from cholera. So if you think about that, every half hour, your mom, your dad, your baby brother, your neighbor, someone in your nearby area was probably dying from cholera in the first 3 days. Over the first week, 75% of the people fled the region. They got out. They couldn't do it. They couldn't stay there anymore. One expert was actually quoted as saying, had they not done that, that there was no doubt in his mind that the results would have been much worse, been way more deaths. The only thing that, in this time, the thing that helped save it was the fact that people were fleeing the scene. By the time the cholera outbreak ended, 616 people had died. So no small thing, right? I mean, this is destroying neighborhoods. If you think about on your street, 3 out of the 4 houses being vacant, and still taking almost 1,000 people out of the central part of London, you start to realize the magnitude of the outbreak. So you could easily call it the cholera epidemic of 1854 instead of the cholera outbreak. And that's what we're going to talk about. It was brought to an end by a man named Jon Snow. It was not this Jon Snow. It was this Jon Snow. That is my only Game of Thrones reference, and I don't even know that, but as I was searching for a picture of Jon Snow, this guy kept coming up, and I was like, oh, that must be some pop culture thing. So I'm throwing away my nerd card here all over the place tonight. So Jon Snow worked with a man named Reverend Whitehead. Got too far there. Reverend Whitehead was visiting the sick. I mean, that was part of his job, as part of what he wanted to do, was he wanted to go out and be with the people that were afflicted by cholera. And so what he was doing was he was going in house to house. He would sit with grandma or grandpa or dad or sister, whoever that passed away, and he would hold their hand as they died, and he would leave that house and he would go to the next house and do the same thing over and over and over again. And Jon Snow was watching Reverend Whitehead, and he was observing what he was doing. And between these two guys, they ended up coming up with the theory or the way to end the cholera outbreak. A little bit of qualifications on Jon Snow. He wasn't just some random guy that was, weirdly stalking pastor. He started as a surgeon apprentice at the age of like 13 or 14. He then joined the Royal College of Surgeons. And if you're like me, not familiar with that term, it doesn't mean like the University of Nebraska-Lincoln. It's more like IEEE or ASM, something like that. It's a group. So he joins this professional society of surgeons. He also, later in his life, joined the Royal College of Physicians. So he's surrounding himself with the best and brightest that London had to offer, right? The best surgeons, the most professional physicians at the time of 1854. He eventually was able to graduate the University of London. So this is not a, nobody off the street. This is somebody that, especially when you consider the time, had education, knew the best theories of the time, and had his finger on the pulse of what was going on in medicine in London in the 1800s. And what was going on in medicine in the 1800s in London was this theory of miasma. And miasma is simply a highly unpleasant or unhealthy smell or vapor. And so what all the learned people at the time were thinking was that what was causing the cholera was there was some decaying material on the shores of the Thames, and it really stank. And it was a smelly area. London was just not a very pleasant place to be in if your nose worked. And they're like, okay, this must be what's going on. This must be the source of cholera, because this just doesn't smell good, right? One of the people that thought that was Reverend Whitehead. As I mentioned earlier, he was working with Jon Snow going in and out. And what Jon Snow started observing as he was watching Whitehead go in and out of all these places is that he would visit person after person after person after person and house after house after house of these people that were dying. And he would hold their hands on the moment they died, and he would read them their last rites and all this stuff. I mean, he's sitting right next to the deceased. And he's able to go house to house to house to house to house. And he's not getting sick. So Jon Snow starts thinking, well, okay, if it's the foul-smelling air, no one is in that foul-smelling air more than Mr. Whitehead is, right? He is putting himself in the midst of that. So why isn't he getting sick? And he starts thinking about this and starts observing it and starts looking into like what else could be the cause. And so what he ends up doing is he starts mapping out a bunch of things. And he starts mapping out where all the deaths were happening. And so as you can see on that map, there's the Broad Street, which is aptly named Broad Street. And then there's all these little black marks all over the place. And especially in looking at it, the bottom left-hand quadrant, there is a big fat histogram, or rather tall histogram. All right? So lots of deaths were happening there. And he starts mapping this out, and he sees that there's this pump right here. It's called the Broad Street Pump. And there's a lot of deaths around this Broad Street Pump. And at this point, John Snow had thought that something besides miasma was causing this. His theory was there was water, but it was some kind of waterborne illness, but he didn't have a way of proving this. And so he starts mapping this out, and you can see that there's a high concentration of deaths down in that bottom left-hand side, but there's deaths all over the place. And so when he's mapping this out, he's thinking to himself, well, it seems like it could be water-related, but man, all these people all over town, all over this part of town are dying. So he starts talking to the people. And what he found was, before the cholera epidemic, the Broad Street Pump was widely thought of as having a rather sweet taste to it. It was pleasant tasting water. And so people would come from blocks and miles away to fill their pails with the Broad Street Pump. And so even after the cholera outbreak, because they didn't know it was water-based, they just thought, well, there's foul-smelling airs. They continued to come to the Broad Street Pump. And so that meant that people were taking this infectious disease and distributing it across the town by going and getting that water. And so it really became, once he plots this out, he can start to see, okay, here is the source, right? It is the pump. And what they found was the way to cure cholera is to stay hydrated. And that's really hard when the way that you stay hydrated is drinking water, and the water that you're drinking contains the cholera bacteria, right? And so what they ended up having to do was to start going to some of these other pumps, right? Some of these places that weren't Broad Street, because it wasn't that the central source was corrupt or tainted. It was just simply that Broad Street pump. The sewage systems in the 1850s in London weren't that great. And so the houses that were right on top of that, their waste was going into the pool that the pump drew from. And so it was making that tainted water. And so once he figured that out, and they go get water from somewhere else, what happens is cholera is cured. So here we are in 2017. We now know, and we've known for over 150 years, how to keep cholera outbreaks from happening. Chances are, if you're in this room in Midwest United States in 2017, you don't know anyone that's ever had cholera. And the good news is that if you do, we know how to fix it, right? If you were to go somewhere where cholera hadn't, the well was, or the water was not pure, we can take care of you. But back then, that was a huge deal. I mean, this was killing hundreds of people a day. Every 34 minutes, someone was dying. Over the course of that couple of weeks, 616 people died. John Snow cures cholera. That's a huge, huge accomplishment, right? But it's so huge, in fact, that there's actually a marker today in London. I had a speaker friend go over to NDC London after he'd heard me give this talk. And so one of the things that he did when he was speaking at NDC was he went and found the Broad Street Pump. And the pump isn't there. It's out for maintenance. But there's a memorial pump there that's not there. So they have this plaque that they put up. But it's so huge that even today, London marks this. I mean, you think about all the things that have happened in London, right, of all the history that they have. For them to mark this kind of shows, how big this really is, how momentous this occasion really is. And so we'll do a quick post-mortem on this whole event. John Snow ends up changing history. The way he changed history, first of all, was he created epidemiology, which is not an easy word to say. That's why I say it fast so you guys don't notice that I'm saying it wrong. But he created this thing that didn't exist before, right? Now we know epidemics, and we know how to study epidemics, and we have movies like Outbreak that talk about epidemics, and Malcolm Gladwell's writing books about how epidemics get started and how they get perpetuated and all this kind of stuff, all because of John Snow. Because he starts studying this, and he's considered by most, his Wikipedia page, in fact, says that he's the grandfather of this epidemiology. But more than that, he changed medicine. Right? Before this, all the smart people that were in the Royal College of Physicians were saying the air stinks, that's what causes cholera. And all the people that were graduating from the University of London's medical school were saying the air stinks, that's what causes cholera. Reverend Whitehead himself said the air stinks, that's what's causing cholera. Until he saw John Snow's work. And then he said, no, this Snow guy, he's onto something. And he eventually came around and became a huge proponent of John Snow, saying, guys, don't cast this guy out of our community. He knows what he's talking about. He's changed it to the fact that he's not only the grandfather of epidemiology, he's also one of the founding people of germ theory, which most of us are thankful for today as we go and watch our doctors wash their hands before they operate on loved ones or before they before they stick their fingers in our throat to check for strep throat, they're washing their hands. And that's thanks in part to John Snow. So he by trying to solve this specific outbreak, changes the course of history. And so before we get into the software side of this and what this means to us as professionals, let's take a quick poll. So if you had cholera today, how many of you would want to be treated with just fresh air? Right? How many would rather have the clean water? Okay, that's the right answer. So you guys are paying attention. The reason we'd want to have that clean water is that we're smart, and we know that this is a solved problem. Why am I going to battle cholera when John Snow solved it 150-some years ago, right? 153 years ago now. Why am I going to let him, why am I going to go and take some way that has been proven not to work when I have that way, when I know the way that does work, excuse me. So with that in mind, let's look at some parallels with software development. Some things that we can apply from John Snow's work on the Ghost map, which is a great book, by the way. It discusses that whole situation. But let's look at some parallels that we have with software. Anybody want to take a guess or know what's on the screen right now? A GUID? No, it's not a GUID. A hash? Yeah. What kind of hash? Maybe a little bit easier. What's it hashing? What's its hashing? What's the hashed thing? Sorry? No, it's not. Maybe. There's a specific word that it's hashing. You want to take a guess? The specific word is password. So this is the MD5 hash of password. And the way that we know that this is an MD5 hash of password is because password is used so many countless times in people's systems that are MD5 hashed that we have millions of copies of this where this is the password for your user account. So this is, you can go on to Google like I did and you can type MD5 hash of password and you get this, and you can type this into Google and you will get, eventually you'll find a site that'll get you the word password. Hashes are one way, right? I'm going to make some assumptions that you guys know some of this stuff, so hopefully I'm making the right assumption because I had to research it, so I assume you guys are smarter than me. But passwords hashing is one way. You can't mathematically get back from a hash, right? Encryption you can. Encryption you can go both ways. But hashing, it's I'm going to do this, and then the way you check to see if you've got the right hash is you hash it again, and then you compare your hashes, and if they're the same, you've got the right thing. So technically, theoretically, mathematically, we shouldn't know that this is the MD5 hash of password unless I were to take the word password and hash it. But we know because, like I said, it's been used all over the place. There are rainbow tables across the internet that will tell you this information. They will help you get MD5 values or get this plain text value of any MD5 hash that you might find. There's a problem with MD5, and that is that it's too fast. And that sounds really weird in today's always connected, I just got gigabit fiber at my home, I want more speed kind of situation, right? Like we're always thinking like I want faster, all right? Broadband isn't fast enough for us anymore. I want to actually see Netflix play the scenes as I drag the bar across. But MD5's problem is you don't want hashing to be fast, because if you can hash fast, then you can calculate lots of hashes in a short amount of time. And if you can start calculating lots of hashes in a short amount of time, you can start finding the ones that match the things that are in your database. Now, you don't want it to be like super slow like the first programs we wrote, but you don't want it to be too fast, right? There's also a problem with how we as developers use the MD5 password or any hashing algorithm, and that is that there's no salt involved. So when I say that there's no salt, we go back to this slide. This is the only thing that got passed into the MD5 algorithm was the word password. And it's every time you pass that in, it's going to produce that exact same hash, 100% of the time. So when I say there's no salt, we need to add something to it. So how do you prevent password attacks? You take a password and you add some salt. A common one is the date time in milliseconds from when you first created your account. The salt itself doesn't matter as long as you know what it is, right? But and as long as you're not using the same salt on everyone, because then you just get back to the exact same problem. Everything's hashed the exact same way. So when we look at hashing a password with salts, what we do is we have this password, and I entered the word password. That's my password because I'm not good at security. And then this 1477615 blah 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 is the time in the epoch time. If you just do like a date time or a date now or a date in JavaScript, and then you spit it out into the number of ticks since whatever that is, January 1st of 1970. And so you combine these two things together and you pass that into an MD5 algorithm and you get something that looks like this. So that already looks different than our other hash, right? It's not the 5F4B blah, 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 blah. And what the nice thing about hashing passwords is that if you then come along and you also don't care about security, so you also make your password, The only difference here is that the last 6 characters, the 754367. You created your password minutes or hours after I created mine. Your hash is going to look totally different than mine. So there is no way looking at those two, unless you're a savant, that you would know that those both are password with some kind of salt, right? That's totally different than what you saw on the previous slide, where every time you use password, it was the same one. So if you were to compromise my database and this was what I had, you're going to have a little bit harder time trying to figure out what these two passwords are, that they're both password, because their hashes look completely different. But this is a solved problem, right? Hashing is I'll say solved. It's solved and continuing to be solved, right, as we come up with better hashing algorithms. So it's not a go out today and learn the best hashing algorithm and you'll never have to learn another one. But the fact that we need to hash and salt our passwords is a solved problem. And yet it's something that we as developers continue to not do, right? There are still people and still websites that MD5 hash their passwords. And you can tell that they MD5 hash their passwords because they're the ones making the news by their sites getting hacked, right? And so this is very much like saying I'd rather have cholera cured by just getting me an air purifier than drinking clean water. I would rather have my passwords just be MD5 hashed instead of salting them. So although I'm talking about salting a password, it also is important to take away, don't use MD5. Even with a salt, don't use it. Use some other algorithm. So if you go into work tomorrow and you find out that your passwords are being hashed with MD5, raise holy hell till you can get that thing changed, because you're putting your users at risk. So that's the first lesson that we can learn. The second one, I don't know if that shows up real well. More people probably know what this is, right? On the left-hand side, what's this an example of? SQL injection, right? So we're saying I want everything from the users table where the field equals my username, or where x equals x. It's going to return everything, right? Because x always equals x, no matter what you pass in for the field. You get this from fields like this, where you put in your email address and then you allow them to put the closing tick mark or x equals x, and then you hit submit. And somewhere in the output of data, you will see all of the users for that site. So there's a few defenses against SQL injection. The first one is you can write stored procedures, whether you're using Oracle or MySQL or SQL Server, Postgres. The stored procedures in those applications will prevent SQL injection. Whatever parameters you pass in, they will make sure that they do not allow them to just dump the table, right? You can also sanitize all your user input. So every field that you have, every email that you have, every first name, last name, city, state, zip, you can take all the pain of changing that and making sure that you're sanitizing the data so that you're stripping out things like or x equals x, or 1 equals 1, or true equals true, or whatever. And that sounds like a lot of work. And it seems like, maybe it would just be better to not worry about it. And if these are our only two options, then that is a pain. But we have to realize that this might be a pain that we either need to figure out a better way of doing, or we just have to deal with. Because what we're saying when we say, well, I don't want to write stored procedures and I don't want to sanitize all user input, is we're saying I want to jeopardize my users' data. I mean, let's be honest, that's what we'd be saying. Thankfully, that's not the only two ways. There's a third way of using prepared statements. And so you can pass in a parameter to your SQL statement, and this will also prevent against SQL injection. The even better news is that your favorite ORM, like Entity Framework or in Hibernate, already do this for you. Others like Petapoco might not necessarily do it for you, but you can definitely do prepared statements in those. So if you're using Entity Framework, or if you're using in Hibernate, then you have a much better, I won't say you're guaranteed to not have SQL injection, because there could be a bug in Entity Framework, right? But you're going to be a lot better off than if you're writing your own 8.0.NET like we used to do back in the day. So what you're probably thinking, though, is that, here it is, 2017, everyone's using EF, everyone's using in Hibernate, nobody allows SQL injection anymore. Well, let me tell you about a company named TalkTalk. They're a European company, I think they're in Britain. And they're a cell phone provider. They're kind of like Verizon. You can get your data and your web and your video and all this other stuff with them. In 2014, they had a huge SQL injection attack on their site, on their system, in which they compromised something like 15,000 users, or I'm sorry, 150,000 users. They lost their credit card information through a SQL injection attack. And so in the ruling, the ICO said that SQL injection is well understood. This is not a professional organization saying this. This is a criminal court or a civil court in the UK saying, hey, SQL injection is a well understood thing. Defenses already exist. TalkTalk ought to have known that it posed a risk to their users' data. So here you have some judge in downtown Omaha slapping your country or your company with a 400,000 pound fine, which is what TalkTalk got. It set the record at the time for the largest fine of something like this. 400,000 pounds because they used SQL injection, because they allowed SQL injection. And you might be thinking, okay, well, that's the UK. Well, there's a company in town that's working with TalkTalk. They did not do this. I want to make sure that's clear. And I don't believe that they were working with TalkTalk when this happened. But TalkTalk is now one of their customers, and they're now writing some software for them. So there is a 1 degree separation from people in this room to TalkTalk, because that happens. You know people that work there, or you know someone that knows someone that works there. So SQL injection is still, sadly, alive and well today in 2017. So what do cholera, password hashes, and SQL injection all have in common? They're all solved problems. We don't see news stories about cholera epidemics with outbreaks. The medical community's got that locked down. They've got it figured out. They know how to solve it. Sadly, though, we do see news outbreaks constantly of such and such site was hacked, such and such site lost data, and it always comes down to SQL injection with bad hashing passwords, like 99 times out of 100, right? And it's almost to the point where when I see those things, I open up the article and I Command F and I search for SQL or hash, and there's always a word in there that says, hey, this thing was hashed, or this was a bad SQL injection. And so the medical community has figured out, let's stop solving solved problems, but we as software developers haven't yet quite figured that out. And I'm not sure why that is. Part of me thinks it's because we enjoy writing software so much that we don't mind the extra work of not using Entity Framework because maybe it's a little bloated, or not doing this because maybe that's not the way I like to do it. And it's only going to take me another half a day to do it my way, and so I'll just do it my way. And in the end, we end up, we get it done. We get it done on time. We get it done, meeting the specs that are in front of us. But we often don't anticipate the bad guys or even the good guys pretending to be bad guys that will come hit our site to see if our data can be compromised. And so as professionals, we need to take a lesson from Jon Snow and the medical community and stop solving solved problems. The next thing we're going to look at is the Challenger space shuttle and some lessons that we learned from there. That is specifically that the inability of Roger Boyce Jolly to stop the Challenger launch actually plagued him until the day he died, which was just a few years ago.
Minus 15 seconds. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Good roll program confirmed. Challenger now heading down range. Engines beginning throttling down now at 94%. Normal throttle for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3 nautical miles. Engines throttling up. 3 engines now at 104%.
Challenger, go and throttle up.
Challenger, go and throttle up. 1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles. Flight controllers here looking very carefully at the situation. Obviously a major malfunction. We have no downlink. We have a report from the flight dynamics officer that the vehicle has exploded. Flight director confirms looking at checking with the recovery forces to see what can be done at this point.
Leading up to that event, there were 7 delays in 7 days before that shuttle launched. It was supposed to launch originally January 22nd, 1986. It did not launch on the 22nd, the 23rd, or the 24th because there were issues with the previous mission that caused that mission to delay. It didn't launch on the 25th because there was bad weather, not at Kennedy, but at the abortive landing center, transatlantic landing center, which is if the shuttle were to launch and there was something that they needed to abort the launch, they could land, I believe, somewhere in Africa. There was bad weather there, so they couldn't launch on the 25th. On the 26th in Florida, there was predicted bad weather, so they scratched that. On the 27th, they again got on the launch pad. They were close to launching. They had 2 separate problems with the exterior door in which they had to scratch that launch. And so in a mere 7 days, they had delayed this launch 7 times. What ultimately happened was on the January 27th, 1986, there was a teleconference in which this man, Roger Boyce Jolly, was an engineer for Thoikel, who was the prime contractor on the shuttle, and they were there to have a go, no-go meeting. I've had these in my career in software, and at the time I didn't realize where they originated from. They originate from NASA, in which you literally are going down the line saying, system 1, are you go or no go for launch, system 2, etc. And on this teleconference, the weather for the 28th was projected to be around freezing, maybe 40 degrees Fahrenheit in the morning of the launch. The engineers from Morton Thoikel, as well as some of the other subcontractors, were protesting, saying we haven't tested some of these systems below 50 to 55 degrees Fahrenheit. We cannot launch. We can't because we don't know what's going to happen. And what ultimately happened was they decided to go above the people, go above the engineers, and get their managers to sign off. And because of those managers signing off, 6 people lost their lives. If you were like me or around my age, you watched this live in elementary school or middle school or whatever you might have been. I sat behind a kid that here we are 31 years later. I still remember the kid saying, "Wow, cool," when that blew up, because he didn't know the magnitude of what had just happened. I remember our teacher running across the room to shut off the TV. And I remember the horrible jokes that were going around in the lunchroom afterwards. 30 years later because of this thing, right? So it is a real tragedy in which 6 people lost their lives, including the first teacher to attempt to go into space. Leading up to that conference call, Roger Boyce Jolly didn't just get on that conference call that day and go, I've got a hunch that this isn't going to work out. Again, like John Snow, he had done his research. So starting all the way back in the previous year's launch, so almost a year to the day, there was this STS-51C launch. And he starts researching, how did that launch go? What systems did they have on that launch? And he starts investigating the SRBs on that launch. And in July of 1985, he writes a memo in which he says these O-rings that are on our SRBs are not suitable for a launch at such low temperatures. So here we have half a year before the launch, he's already writing memos. He's placing a stake in the ground saying, no, this is dangerous. Another engineer wrote a memo that was simply titled, "Help Me," because he recognized the problem of what might happen on this launch. And they created this task force to look at some of these things. And Boyce Jolly was on this task force. And he quickly realized that this was a task force not meant to solve the problem, but simply meant to appease him and shut him up, basically. And so at that, he basically quit the task force. It wasn't worth it to him. In the fall of 1985, he wrote a memo in which he uses the phrase, "There's a distinct chance of failure. If we proceed with this launch without changing these O-rings, there is a distinct chance of failure." So here we have 4 months before the launch, engineers building the systems, warning NASA, hey, something bad could happen. When it all came down to it, that call on January 27th, 1985, the O-rings were the topic of discussion, and they were labeled a criticality 1. And what criticality 1 means for NASA is that all systems have backups, right? So criticality 1 means you're not allowed to rely on your backup to launch. If you think the primary system might not work, then we have to scratch the launch. O-rings were criticality 1. According to NASA's own standards and own guidelines, they should not have launched because the engineers were saying, listen, this thing that's happening on a criticality 1 system might jeopardize the lives of the astronauts going up or might just jeopardize the mission in general. And yet, They didn't care. They pressed Boyce Jolly, they pressed some of the other engineers to say, give us a go ahead and go. And you can almost hear it as software developers. I place myself in that room and I can almost hear them going, come on guys, we tried on the 22nd, we tried on the 23rd, we tried on the 24th, we tried on the 25th, we tried on the 26th, we tried yesterday, or we tried today. We have to do this tomorrow, right? They're applying that pressure to the engineers, and to their credit, not a single engineer that was at not management level, so an actual, let's just say, real engineer, not a single one of them backed down. They all said, no, we can't launch. And so they went above their heads and the managers signed off. And what happened over time, there was a congressional investigation. Physicists like Richard Feynman were a part of that investigation to discover what really happened. Lots of theories were out there. I think the one that was most telling was Ken Iliff, former NASA chief scientist, said that NASA violated a couple of mission rules, and that was the primary cause of the Challenger accident. Nobody is denying that O-rings were criticality 1. No one's denying that the criticality 1 means we can't launch if we have to rely on the backups. What they did though is they said, yeah, but let's just go ahead and do it anyway, right? Like, what's the worst that could happen is you can almost hear them saying. I label this as go fever. And that's a really bad slide in here. So that's in red, it says go fever. Because they'd already tried. 7 times they tried, right? They had to get this up. I mean, this was starting to be a PR nightmare. We have this teacher that we're so proud to say we're launching into space, this civilian, this teacher, and she's going to go up into space, and she's going to be the first teacher, and this is going to be a great thing. And every time we have to go to the news companies, the news channels, and say, no, we didn't launch today, right? So there's this go fever. And that, to me, is the biggest cause. There's already, obviously, from some of your glances, an apparent correlation to software in that we all have go fever. We've all experienced go fever, right? What's the first thing to cut at crunch time on software projects? Testing, right? Didn't even have to finish the sentence before somebody spit it out. And that's true. Testing is the first thing that always gets cut. In every project that I've ever been a part of for 17 years, testing gets cut right out of the gate, right? So yeah, testing. So we're going to talk for a minute about a situation in which I think we might experience go fever, and we might experience some of the pressures of go fever. And that's test-driven development. And if you know me, you know that I wasn't going to get too far into a presentation where I wasn't talking about test-driven development. And just to set the stage so that everyone's on my definition of TDD, and you guys can have your own afterwards, but I have the mic and I have the floor, so we get to use mine. TDD is you write a failing test. So you write something and you say, I want to test that when I add 1 + 1 it equals 2, and right now it doesn't compile. That's a failing test, right? So you write a failing test. Short, simple, not a huge test, hopefully just a couple lines. Testing first, in this way, writing the test first, lets you test that what you think you're testing, you're actually testing. So that's why you write the failing test first. You're now testing your tests. And so if you write your tests after your code, what you find is that in order to really verify that your tests are testing the things you think they're testing, you either have to go break the code or you have to break the test and see that they fail. And what happens? Nobody does that. Nobody does that. I'm on a project right now where we're introducing some people to testing, and you can tell the ones that write the test before and the ones that write the test after, because 9 times out of 10, the people that write the test after, their test passes if I go delete the code that's under test. And hopefully we catch that stuff on pull requests. That's kind of my mission in life right now, is to catch that and go, hey, look, if you delete line 132 out of your source code, your test still passes. This is a bad test, right? So that's why you write your test first. That's why you make it fail first. After that, you make it pass, and you write the shortest amount of code, the simplest amount of code to make it pass. Again, you're not trying to solve everything. You're trying to take a baby step. After you've done that a few times, and when I say a few times, I'm saying maybe within the course of 2 to 3 minutes, then you have a chance to refactor. And if you're like me, refactoring is the reason I write code. It's not to write it the first time, it's to rewrite it and delete your code is probably why I get out of bed in the morning, or delete my code. But when you have these test suites, you can do that because you know, hey, my code's tested. So if I change this stuff around and suddenly everything breaks, then I forgot something, right? I left off a decimal place, or I did the wrong step, and now everything's broken. But this is something that is maybe the most or maybe the least controversial thing in software development, right? Everyone says, yeah, we should test. Of the people that say, so in my 17 years, I don't think I've ever met, maybe more than 5 people that have ever thought unit testing is bad in general, right? I've met far, far fewer people who think TDD is a good idea. Most of the people who think TDD is a good idea still don't practice TDD, right? So there's a lot of people that are like, yep, unit testing is great. There's some fewer people that are like, TDD is okay, and then there's a small minority. I might say in this room, just looking at it, there might be 4 people in this room that consistently do TDD. It's not saying anything about you guys. It's saying the numbers of the developers I've met, right, playing the odds. What happens, though, is we hear this, we must ship, right? We get that go fever. Come on, guys. We tried to release in January. We tried to release in February. We've got the big conference coming up, right? Our client's doing some big trade show, and if they don't get a demo of their software, then what's the point of going to the trade show? I've heard that within the last year, right? Oh, we have this deadline. The client's client needs this by such and such date. We have to get this out there. So we're going to just disable all the testing, right? That was on a client that I'd worked with. That was the first thing they told me when I asked about testing. Like, oh, we're just going to disable those files because we're on such a short time frame. So it's this idea that we have to ship. And what I want us to get to, though, is that we need to ship not just software, but we need to ship working software, right? It didn't do the NASA any good to launch the shuttle, right? They needed to launch one that wouldn't explode. They needed to launch one that would protect the lives of the people that were on board. We as software developers need to ship working software. We need to ship software that doesn't have SQL injection, that doesn't have hashed passwords without a salt, doesn't use MD5 and any other litany of security vulnerabilities and other type vulnerabilities. And so it puts the onus back on us in which we must ship working software. And one of the things I've found in my own experience is that TDD for me is a great way to prevent against go fever. When you write the test after, it's so easy to say, well, you go to stand up in the morning and you're going around the room and you say, oh, I got the feature done. I just have to write some tests, then I'll create the PR, right? And every product owner that hears that says, what if you don't write the test? What if you just create the PR now, right? Whether they say it verbally or not, they say it in their head. They probably say it with their eyes. They might even say it verbally, right? If you're doing test-driven development, though, there is not a point in time in which you can say, I've got the feature done, I just have to write the test, because they're so intermingled. You are writing the test as you write the software. You can't have a feature unless it has tests, so you're already preventing that. It might take you a little bit longer, but it's making sure that you're shipping the working software. And as you talk to people that have done TDD as long as me, or let's be honest, even longer than me, because I haven't been doing it that long, they'll tell you that for them, it's actually shorter or about the same time to write TDD code versus non-TDD code, because you are still going to test it, right? You're still going to pull up the app. You're still going to go in the browser. You're going to click through to at least see some things, right? And you don't ever count that time as testing in your head. You're just like, oh, I'm going to see if it works before I create the PR, right? But that counts, right? It's still time you have to do. So we have to focus on this shipping working software. And so you're probably thinking, most of us here, again, playing the numbers, I don't know you guys, except for a few of you, probably just think, oh, but I just write web applications, right? What's the harm? It's a web application. What's the worst that they could do? So I have this slide right from the headlines, and I've been giving a version of this talk for at least 3 years now. And this slide is always different. And the great thing and the horrible thing about the software industry is that I never have to go a week, maybe a month, without changing this slide. Every time I give this talk, I go to Google and I just look for catastrophes in software development, and I find something within the week or within the month. So this one is the Qihu 360 at Pwn2Own 2017. So Pwn2Own is a competition in which security firms try to break software. That's where you see a lot of these zero-day attacks. It's often they try to show security vulnerabilities of your browser, of OS X, of Windows, that kind of thing. So this month, in March of 2017, Qihu 360 won Pwn2Own, and we all lost by them winning, by the way. They won something like $100 and some thousand with their security breach. And the speculation around the security breach, before I tell you what it was, the speculation is that they probably had this for a couple years, but last year's payout was only going to be $75,000, so it really wasn't worth them exposing their secrets to their competitors of how they break software. But now it's up over $100,000, so now maybe it is worth it, right? And so the theory is that the people that were at Pwn2Own and whatnot, they all said, yeah, this is probably something that's been around for a while, that they've known about for a while, right? Nobody shows up to Pwn2Own with a thing like, hey, let's try this, right? They come in with their flash drives blazing because they know the hacks they're going to do. And so this is something that's been around. So what did Qihu do? To quote their executive director, Xing, he says, we used a JavaScript engine bug within Microsoft Edge to achieve the code execution inside the Edge sandbox. And we used a Windows 10 kernel bug to escape from it fully compromise the guest machine. Then we exploited a hardware simulation bug within VMware to escape from the guest operating system to the host one. It all started from and was controlled only by a website. So from this website, they now owned the machine. They could do anything they wanted in Windows. And we have all these, I mean, you can hear the layers that they went through, right? And if you're like me, before I read this article, I was thinking, well, like, okay, so they got through IE and they're in IE sandbox. Like, yeah, that's bad, but it's not horrible, right? Like, it's not that bad. I mean, it is. And then you think, okay, well, so they got past IE sandbox, or they got past IE, but they're still in that sandbox, the way Windows hosts those things. Well, they got through that too, right? They got past the VMware through a vulnerability. Now, granted, they had to have 3 specific attacks lined up, and all the things had to happen the right way. But if you're just writing web applications, all they did was write some JavaScript that they knew broke the IE JavaScript engine, which compromised all of this. So all from a website. And if you think about the fact that Raspberry Pis are shipping left and right, and the IoT phase is kicking off, and all of that can be written with JavaScript, you start to realize how much more of this actually matters. It's not just writing a website. Also, not only, let's say we are just writing applications, right? For most of us here, you will likely retire writing something besides a web application, provided that you're not retiring tomorrow. And if you're retiring tomorrow, you shouldn't be at a user group. You should be, doing something fun. Not that this isn't fun, but you should be doing something else. I started writing C++ applications for Windows, compiled applications. I moved to WinForms applications and then to a web server and now single-page apps. So in 17 years, I've kind of made some transgressions. I've made transgressions. Let's just be honest. I've made some transitions as well with my transgressions. And I have no intent in retiring in the next, 25, 30 years. So probably going to do something different besides websites, because I'll tell you right now, I cannot write websites for the next 30 years. I cannot write web applications for the next 30 years. I can't do it. I like software. I cannot do that for 30 more years. So I'm going to wind up on something else, right? And so what is that something else? Maybe it's a self-driving car. Maybe it's something that controls the locks to your house. I don't know. But keep this in mind, is that the S in IoT stands for security. That's been going around on Twitter a lot, and that's kind of where we're going, right? So IoT is starting to take off. VR is starting to take off. And those are things that I'm interested in, and maybe I'll wind up there, right? But we're repeating the same mistakes over and over and over again, right? IoT is not learned from the previous 30-some years of software development in terms of things not to do. And so as we think, oh, I'm just writing websites, how bad could it be? Keep in mind that at some point in the not too distant future, you'll probably be writing something besides a website. So we've talked about we talked about Cholera, we talked about the Challenger. Why am I up here, having this, what's the big deal? Why am I here? Why do I want to talk about professionalism so much? Well, we're going to go through a series of things. It's going to get worse, right? It's like that old kid song, could get better, but it's going to get worse. So it's going to get worse. The first thing, the lowest thing, the smallest part of the big problem is that you could waste time and money. Brian and I were talking about this before the thing started tonight. In 2011, I was at Target over lunch. I ran in and grabbed a sandwich and like a bottle of pop, maybe something else. And my total was like $7. And I gave the lady my card, and I was declined. And I'm sitting here starting to panic for lots of reasons. One, I'm thinking, what does this lady think of me that I can't afford $7 on my debit card? Then I'm thinking, wait a minute, we just got paid. What happened to all of my money? Where did it go? Did I double pay the mortgage? Did I screw something up? Then I start thinking, oh no, something happened to my account, right? Thankfully, I had the $7 in my pocket to be able to pay in cash, and I didn't think about it until I got home that night. And I was like, I need to call the bank and see what happened. I probably should have called earlier, but I think I was new at the company at the time and didn't want to be on the phone, right, because that looked bad. But what ended up happening was, I called the bank, and they said, oh, Mr. Taylor, you do not appear to be in Italy right now. And I said, you are correct. I'm in my house in Nebraska. And they said, okay, great. That's what we thought. Someone is trying to use your card in Italy, so we've already canceled the card. We've actually already shipped you a new card. It's in the mail today. Like, we already did it. So that's why you couldn't use your card. I'm like, oh, okay, great. Thankfully, they only took my card information. My wife's card still worked. So I had a way to get money for a couple days until my card showed up. But other coworkers weren't so lucky. I go into work the next day, and I'm just thinking, man, I had bad luck. Somebody somewhere took my card number. But I start hearing, rumblings above the cubes and everything of people talking to their bank, and I find out that so many of us lost our credit card information. I was one of the lucky ones, and that First National Bank did an excellent job. They caught the transaction. They stopped it. They didn't let any money leave my account. But other people were with other banks that weren't so lucky, and they had to close down their accounts or had their accounts go negative because they did let the money go out, right? And people actually did acquire $900 leather shoes in Italy from my coworkers' stolen credit card information. So how does all this play in? Well, the company at the time had just released, or not just released, it just unveiled a new break room in which they got rid of the vending machines, and instead they installed like a kiosk system, so it was kind of like a gas station type thing. And you were supposed to use like a little baker's card type thing to go scan. And you could load that up on the web if you wanted to. Or if you forgot, like I did one day, I scanned it, I didn't have any money on that, I didn't want to go all the way back to my desk to load up money and come back, you could swipe your card. And so I swiped my credit card, bought, paid the $2 for a candy bar and a Coke, and went back to my desk on my own merry way. The software developers at that company made a couple mistakes. First of all, not at the company that I was working at the company that sold the thing that let me scan the card. First of all, they had a flag that said, do you want to encrypt the credit card information? So that's the first mistake. That shouldn't be a flag, right? That should just always be yes. I always want to encrypt it. The second mistake was that it was either set to false by default or that was part of the setup routine. So when they unveiled this new thing, everyone's credit card information was going out over the phone line to whatever servers they wanted on the internet in plain text. And the outcome was, and this actually still frustrates me to this day, was on the back of the break room door was a letter from our company saying, hey, here's what happened, we're sorry. How many people look at the back of break room doors, right? Like, I didn't even normally go into the break room, but I just happened to see it that time, right? I was thinking, like, no, you guys should be standing on the top of the desk shouting this out, right? Or sending out emails. Now, people lost so much time and so much money. I mean, most of them got their money back, I think. But if you lost your account and you had to go through and set up new recurring direct deposits and new recurring debits and get new credit cards and you closed your account, so great. My wife lucked out because we had the same account and they stopped it. I was able to use hers. But if you had an account that got closed, not only do you not have money, but your spouse doesn't have money. And if it's the beginning of the month, when's that paycheck going to come in? When are you going to refund the money that shouldn't have been taken out of my account, right? You have all of these issues start coming into play, all because of a stupid checkbox, because of a Boolean, right? That's the low end of the totem pole of what we're talking about here, right? Waste time and money. Next, you might lose someone's data. It's kind of related, right? I don't lose my time and money if I don't lose my data. But this is so easy, especially with SQL injection. It's so trivial for data to be gone. Target loses some 30,000 credit card information, and LinkedIn gets hacked and loses their data, and all the recruiters were crying, I guess. Were you guys crying when LinkedIn got hacked? We were rejoicing, but maybe not. So the next step is that someone loses data, right? Or you lose someone's data. We're not going to spend a lot of time on that because it's so similar to losing time and money. The next thing, though, is that someone's injured. When I first got out of school, I was at Caterpillar in Peoria, Illinois, and they did a one-year rotation for engineers. So you spent the first year rotating through different departments. And my first stop was in the electric power generator group. So these big honking 15-cylinder engines that are natural gas powered that are running things like Children's Mercy, or not Children's, yeah, the Children's Hospital, all the hospitals in town. When the power goes out, things like the Caterpillar generators kick on. And every piece of equipment that came off of a Caterpillar factory line at the time and since has ECM on it, an electronic control module, just like your car does. And so my job as a 1 year fresh out of, not even a year fresh out of school, was to write a tester for their ECM that they were going to put on these generators. And they weren't relying totally on the automated testing, thankfully. They were still going to do a lot of manual testing, but they wanted to get a lot of the crud out of the way, like, hey, if we turn the ECM on, does it come on, and that kind of stuff, right? Things they had to verify, but they didn't want to necessarily pay someone to sit there and take the half a day to do it. So the thing with generators is they're no good unless they're putting out a lot of voltage and current. And the thing with testing is it's no good unless you can verify that they're putting out a lot of voltage and current, right? So these generators, to simulate them, we had simulated loads on like a server rack. And it was 480 volts. And it's not a normal plug-in like these. I mean, it's a fire hose that you shove in the wall and you turn so that it locks it into the wall. Excuse me. And you were supposed to, if OSHA was watching me, I was probably supposed to do this, but put on rubber gloves, put on rubber booties over my feet so that there was this insulation effect, right? No one ever did. And thankfully, to my knowledge, no one ever got hurt, or at least none of the people I knew, right? But this is serious voltage, right? If you're lucky, probably, it'll do severe damage. If you're unlucky, it'll kill you. But looking back on that, I was completely oblivious. I was 22, 23 years old. I didn't necessarily know what I was doing. It would have been very easy for me to toggle a switch that says, yep, the power's off and the power be on, right? Same thing that just happened with credit card information, right? I could have made that mistake. So even though I'm blasting the credit card people in that previous story, like it could have been me, right? And that's part of what the big deal is too, is it could have been me. Like I said, it didn't happen. But if it did and someone goes, oh great, the power's off, and they touch something, what most often happens with electricity is not the fear of getting electrocuted, it's what happens to you when you get shocked, right? So falling off of a lab bench is much more catastrophic than the actual electric shock if you're working with small voltages. It's much more likely that you'll hit your head on the concrete and give yourself brain damage than it is that the electric current did anything to you. But at 480 volts, it's going to send you across the room, right? And so it could have sent someone across the room into a rack, into a lab bench, something like that, that very easily could have been injured just because I wasn't taking my job seriously. And it wasn't that I wasn't taking my job seriously, it was that I didn't know, right? Like I didn't know what I could have done or could not have done there. Thankfully, I had people in my life, engineers, not software engineers, but engineers who continually reminded me that you're dealing with big equipment. And if something happens on that big equipment on a job site, it could just drive over somebody, right? Or something like that. So I had that in the back of my mind, but it was really by dumb luck or by providence that I didn't injure someone. So that's the next thing. And really there's only one other thing, and that is that someone dies. And when I first thought of these slides, 3 or 4 years ago, I thought, okay, that's going to happen at some point, right? And I started talking to people before I gave the talk, and I realized, no, it's not going to happen at some point. It has happened numerous times in history. Software development has killed people. The earliest one that anyone really knows about or talks about is in the 1980s. There was a radiation machine. I forget the name. But basically, it was the first version that didn't have hardware over safety controls. They used software safety controls, and the people overrode the software safety controls, and they gave people getting treated for cancer too much radiation. And it killed a couple people, injured far more. And that's been solved. I mean, not been solved, but that doesn't happen much anymore. But the one that sticks in my mind is the Toyota unintended acceleration from a few years ago, whatever that was, 2012, 2013, right? These Toyotas would just take off, right? You're slamming on the brake, you're slamming on the gas, you're trying everything you can. It doesn't matter. You're taking off. There was one gentleman who was in a Toyota. It crashed. It killed his wife, his daughters. He was the only one that survived. Dateline, runs a deal on him because clearly he just wanted to off his whole family and go live the bachelor life. He spent several years in prison because they convicted him of manslaughter before he's finally released because they realized that Toyota has this bug that just accelerates the car despite whatever you can do. And so this guy, lost 3 of his loved ones, lost some of his own life and freedoms in going to prison. And the problem is, or not the problem, part of the problem is the code was so horrible you couldn't test it. The code was so horrible, there were over 10,000 global variables in this code, right? And we hear that number, and it's almost hard to comprehend. And I start thinking, as I often do when I try to place myself in the position of NASA or whatever, and I start thinking like, okay, I know what happened, and I don't, but in my world, I know what happened. Somebody couldn't come up with a better way, so they added 1 global variable, right? What's the harm? It's only going to be 1, right? And it stayed that way for a while, and then someone else couldn't figure out a good way, so they added a 2nd global variable, and before long we're at 10 or 15 or 20. Eventually we get to 100, and then it's at that point it's like, well, who really cares? We already have 100. If one of these hundreds isn't going to break, then what's the next 100 going to do? And then we get to 10,000 global variables, right? You could almost say that they weren't doing their PRs correctly. I don't know if they were doing PRs, but you could almost say that they weren't reviewing their code correctly, right? So they have these 10,000 global variables. They have no way of testing the system. And they have no way of knowing whether it's working or not. And so what ends up happening is Toyotas take off and kill people because of software developers like you and me, right? Because we got lazy and it was Friday afternoon. I really don't want to do this PR. And yeah, that looks good. Hit approve and merge and let's go, right? And we just introduced the first global variable with no malice in our heart, right? We weren't trying to harm our users, but we just weren't careful enough to not harm them. So that all leads to regret for you as a developer. There was a man, another engineer on the Challenger named Ebling. I don't remember his first name. He actually suffered deep depression. He's never been able to lift the burden of the guilt from 1986 till now. I think he's still alive. If not, he's passed away within the last year. He recently, on the 30-year anniversary, there was a reporter went out and talked to him, and they showed him the clip again. And as he was watching this clip, the clip that we watched, he said, "I could have done more. I should have done more." 30 years later. An engineer who, tried to stop it said, I could have done more. He says the same thing today, he said that when he first watched it. He says the same thing today, 30 years later. This is quoting from an article. He's sitting in a big easy chair in the same living room, his eyes watery and his face grave. The data he and his fellow engineers presented and their persistent and sometimes angry arguments weren't enough to sway Thoughtful managers and NASA officials. Ebling concludes that he was inadequate. He didn't argue the data well enough. In contrast, Boyce Jolly, who was the man who had the picture up a minute ago, he says we were talking to the right people, and they had the power to stop it, and they didn't. So he was able to deal with his guilt a little bit in that, like, hey, we did the right thing. We raised this up, right? But here you see the contrast between these two engineers. They both did the same thing, and one, 30 years later, is still living with this idea that, like, I could have done more. And I don't know what the guy could have done, right? Like maybe run out on the launch pad or something, but there wasn't much he could have done. And what I want us to realize is that if we're not careful, that could be us, right? Like I don't want anyone in this room to 20 years from now be still regretting a decision you make tomorrow or make next week or made last month, right? So that's the big deal, right? Is we're impacting real people with our decisions here. So let's sum up. What's the TLDR? What's the summary here? First things first, we have to quit solving solved problems. We have to. We're smarter than that, guys. Come on. We know things are solved. We know, like, why are you writing an ORM yourself, right? Like, yeah, maybe EF isn't perfect. I don't like it, but if it means that I don't expose my users' data, I'll use it, right? Or I'll go join an open source team to help write a better one, something, right? But like, let's quit solving solved problems. Let's quit exposing our users' passwords. Let's quit allowing SQL injection to happen. So that's the first takeaway that we have to realize. And that's the whole going back to cholera, right? We know how to cure cholera. Let's quit trying to do it with air fresheners. Don't succumb to Go fever. And this is way easier for me to say than to do, I'm sure. I've been guilty of probably being on both sides of Go fever. I probably tried to enforce, probably tried to spur people on in spite of me knowing that that's not the right thing to do. But don't succumb to it. Roger Boyce Jolly didn't. He ultimately, he didn't fail. The mission failed. It cost people their lives, but to his dying breath, he knew he did what he could do, and he said, do not launch this, right? They put him in a position where they asked, can we launch this? And he said no time and time and time and time again, right? So don't succumb to Go fever. The other thing that we need to do is we need to learn from other professions. We're still a baby profession when you think about it. Software development in its entirety is what, 50, 60 years old maybe? Civil engineering dates back to the Roman Empire. Mechanical engineering, probably not much longer after that. Even electrical engineering is a few hundred years old. Medical, we can learn from scientists. We can learn from all these other professions. And if we don't learn from them, then we're going to be kind of like my view of JavaScript right now. Now, I love JavaScript. I enjoy writing. The only language I enjoy writing more than JavaScript is Elixir, and I don't get to do that. So JavaScript is my favorite. I'm almost smiling when I'm writing JavaScript. But there's a huge problem with the JavaScript community, and that is we keep reinventing the wheel. So we keep going back to things that we tried in C++, and we don't learn from those lessons. We start from the starting point, and we make the exact same stupid mistakes they did, and then we try something else, and we make the exact same stupid mistakes they did. We have to learn from other professions. We have to learn from history and stop repeating ourselves and stop making the same mistakes. Ultimately, though, our industry is judged by your performance. Lawyers have the state bar. Doctors have the medical boards. Accountants have CPA certifications. Civil engineers have the professional engineering license. We have nothing. We have our performance. We have the performance of the people that are in this room. How I write my code tomorrow is going to determine how people look at you on Monday. And that sucks. It's not fair for you, especially if I suck at writing code, but that's the way it is, right? And so I'm calling us to rise up and say, listen, I know that my industry is judged by my performance and your performance and your performance, and so I'm going to take that seriously. I'm going to do something about it. I could wipe out a database today or tomorrow for my client and get fired from my job, and I can tell you by Monday I'd have another job and they wouldn't even know that I just lost everybody's data, right? And then when they find out, they go, oh man, this guy's horrible. I bet all software developers are that way, right? Most of us have friends that aren't software developers. I have a friend that runs a gym, and I can't tell you the number of stereotypes he has about software developers because of the ones he met. And I want to say, like, yeah, but that's not me, but it doesn't matter because in his mind it is, right? And so, his thing is we're all writing code on the power of pizza and Mountain Dew and Daft Punk, and only some of that's true about me. But still, like, that's the perception, right? Is that what you're doing today will determine how people look at me and how they look at the people sitting next to you. And the other big thing is that you as a software developer, to take all this negative stuff that I just talked about for the last hour and turn it into something positive, you have the power to protect people. And that's the bigger takeaway is we have the power as software developers to protect people. That means we have to stop solving solved problems. That means we have to stop having Go fever and succumbing to it, right? But we have the power to protect people. We have the power to not let my credit card get stolen because I wanted to buy a Coke and a candy bar. We have the power to make sure that when my aunt and uncle are driving down the road in a Toyota that they don't worry that their car is going to take off, right? We have that power. And I think we just need to realize that and then start capitalizing on that. So thank you.